All right, this is the homework assignment for angles in the coordinate plane. I'm going to go through some of the problems. So the first one, 360 degrees. 360 degrees, you should just know, is equivalent to 2 pi radians. So that's a pretty quick conversion. Of course, there is the formula. This is how you would do it with the formula, but this is one you should just know. Really, anything that falls on the unit circle, you need to get to the point where you just know it. 720 degrees, that is, of course, just 360 times 2. We know 360 degrees is 2 pi radians. So if we take 2 pi and multiply it by 2, we get 4 pi. Again, you could use the formula, but that's another one you should just know. 3 pi over 4. Again, this is one that falls on the unit circle, one that's a little bit tougher to just memorize, but of course that's 1 1/4 pi, or 90 degrees plus 45, which would make it 135. This is how you would get it using the formula. All right, next section, we're sketching the following angles and then stating which quadrant the terminal side lies in. Remember, terminal is the ending part of the angle. So let's go ahead and sketch. Let's do letter B, negative 2 pi over 3 radians. So if you need to, convert that 2 degrees to help you out. So that's negative 120. And we're going to go clockwise. It's a negative angle. Remember, each quadrant is a half a pi, or pi over 2. So 2/3 should just be a little bit more than that first quadrant. Which is exactly where negative 120 degrees would be. So the answer, this is not quadrant 4, this is quadrant number 3, because it wants to know what quadrant that terminal side lies in. Here we're stating the angle that's coterminal to the given angle. Remember, coterminal means has the same initial and terminal side, but it comes from the other direction. So for instance, letter B is negative 70 degrees. So I'm going to go ahead and sketch that. You know, it's really safe to do that in this problem. So negative 70 would be roughly right there. So coterminal is going to be coming from the other direction. Now, since it's coming counterclockwise, I know the coterminal angle is going to be positive. Just a quick check is what's 360 minus 270, so whatever's left over from full 360 degrees, and that is positive 290. So where the absolute value of the given angle and the coterminal angle should always add up to 360. Here we're determining the reference angle, which is kind of like the shortest degree measured to the x-axis. So I'll go through a couple of these. 300 degrees. We're first going to sketch that angle. So that's 300 degrees. Sometimes what I like to do is I like to annotate that angle, and I know each quadrant's 90 degrees, which means this piece right here. All I have to add up to give you 300. So the question is, what's the shortest distance to the x-axis from this terminal side? The shortest distance to the x-axis I've got labeled in blue. And of course, that would be 60 degrees. Negative 150. And that's going to be in quadrant number 3. I'm going to quickly annotate it. That's 90. That piece would be 60. So the shortest distance to the x-axis from that terminal side would be right there. I probably don't have this one drawn to scale. But either way, it's 30 degrees. Remember, the reference angle is always positive. So even though this angle measures negative, the reference angle is a positive 30. Finally, if they give you the angle measured in radians, your reference angle should be in radians. So I'm going to sketch this one without converting it to degrees. Negative pi over 4. Each quadrant is about half a pi, so pi over 4 is half of that. So the question is, that is the angle, negative pi over 4. That's already the shortest distance to the x-axis. So the reference angle for this one is pi over 4.